What if an AI could actually teach itself to get better at pretty much anything? Well, today we're diving into this incredible new paper that explores exactly that. It's a new framework for creating AI that improves all on its own, without a human having to constantly step in.
But first, here's a weird question. Why is it that sometimes the more an AI does something, the worse it gets? You'd think it would be the opposite, right? It's this strange paradox where, in the process of trying to learn, it actually starts to forget crucial information. So, what's going on here? Well, the researchers behind this paper found two big culprits. First, there's something they call brevity bias. This is where the AI, trying to be efficient, summarizes its own instructions, but it cuts out really important details. And second, there's context collapse. You can think of this like making a photocopy of a photocopy of a photocopy. With every new version of its instructions, the quality degrades, and key information just sort of fades into nothing.
So, what you end up with is this static, worn out playbook. The AI's core strategy guide just doesn't evolve. In fact, every time it tries to update itself, it actually gets a little bit worse. It's stuck, and it can't really adapt to new situations or learn from its mistakes in a meaningful way.
Okay, so if the problem is a static, degrading playbook, what's the solution? Well, the answer these researchers came up with is to create a living one. So let's meet their new framework. It's called ACE. ACE stands for Agentic Context Engineering. And that word, agentic, is the key to everything here. It means the AI acts as its own agent. It's in the driver's seat of its own improvement. So instead of a fixed rulebook, ACE treats the AI's knowledge like a dynamic playbook that is constantly learning, adapting, and getting better on its own.
And this really gets to the heart of what ACE is all about. It's not just a set of instructions. It's a living, growing library of strategies. The AI is actively gathering new ideas from what it does, it's refining the tactics that work, and it's organizing everything so it can use it later. It's a system that's literally designed for constant growth.
So how does this stop the AI from forgetting? Well, instead of rewriting the entire playbook and risking that information loss, ACE makes smart, structured, incremental updates. It adds new learnings in a really modular way. This keeps all the important details safe and sound and completely avoids that context collapse problem we talked about. And, big bonus, it's built to work incredibly well with today's super powerful long context AI models.
All right, so we've got a living playbook that gets smarter over time. But how? What does that learning process actually look like? Let's break down how it works.
It all boils down to this really elegant three-step loop. First, there's generation. After the AI does a task, it brainstorms new strategies. Then comes reflection. This is critical. It looks back and analyzes its own performance. What worked, what failed, and most importantly, why. And finally, curation. It takes the winning strategies, integrates them into its playbook, and throws out what didn't work. This cycle just repeats over and over, constantly making the AI better.
Now this is a huge deal. Normally, to improve an AI, you need massive amounts of data that humans have painstakingly labeled by hand. It's slow and it is incredibly expensive. ACE doesn't need any of that. It learns from natural feedback. Basically, just by looking at the results of its own work, it learns from its successes and failures out in the real world.
Okay, so the theory sounds amazing, right? A self-improving AI sounds like science fiction. But does it actually hold up? Well, the researchers put AC through its paces in some really demanding challenges. And let's just say the results were pretty stunning.
I mean, you don't even have to dig deep into the paper. Right there in the abstract, they make it clear. ACE wasn't just a little bit better, it was consistently outperforming really strong established models. That definitely sets the stage for some impressive numbers. This chart gives you the big picture. Across the board, on all kinds of different tests, the AI models that were enhanced with ACE just did better than the standard versions. But let's drill down into the specifics, because this is where it gets really good. Okay, first up, on general agent benchmarks, these are tests that measure an AI's ability to handle a whole range of different tasks. ACE delivered a performance boost of over 10%. Now, in the world of AI development, a double-digit jump like that is a massive leap forward. But it's not just a jack of all trades. They threw it into the super specialized world of finance, and even there, it delivered an 8.6% improvement. That proves it can adapt and excel even in really complex niche areas.
But the real showstopper, the result that made everybody sit up and pay attention, came when they pitted an ACE-powered agent against some of the best AIs in the world on a public leaderboard called AppWorld. And you have to see this. On the absolute toughest challenges in the competition, the top agent on the leaderboard, a massive closed-source proprietary model, scored an 85.2. The ACE agent scored an 86.1. Now here's the crazy part. It did that running on a smaller open-source model. It didn't just win, it won against a bigger, more resource-intensive opponent. This is a game changer. It suggests that a superior strategy can actually beat brute force.
So, what does all this mean for the future? I mean, the results are incredible, but the implications are even bigger. This really does feel like it's pointing us in a whole new direction for AI. The big takeaway here is that ACE is way more than just a clever trick. It's a fundamental shift in how we think about building AI. It's like a blueprint for creating systems that can improve themselves efficiently and at a massive scale without needing us to hold their hand the entire way. And this matters for all of us. We're talking about more effective, more reliable AI assistants in our daily lives. For businesses, it means adapting AI for new tasks way faster and cheaper. It paves the way for a future where our AI tools are always getting smarter and where top-tier performance isn't just for those who can afford gigantic models. So this research really leaves us with a profound question. For all of human history, we've built tools. Now we're on the cusp of building tools that can improve themselves. So what happens next? What new possibilities open up when our creations can truly start to learn all on their own?